Hello, we're a multidisciplinary group of engineering students working on a garbage disposal system. In this video, we'll be going through the system of interest and drafts, the system of context, the scope of initial design, specifications, stakeholders and their concerns, subsystems of the system, internals of the system, key performance parameters, a PO matrix for the alternative solutions, and finally the simulation software. Brainstorming. The task we received was to come up with a solution for autonomous transportations in a car-free Oslo. The initial stages, we figured out that we wanted to focus on a single part of the problem rather than the entire problem. We did some brainstorming and that resulted in mind mapping. From that session, we found out that we wanted to focus on the transportation of garbage. We saw an opportunity to fill a gap that would appear due to the exclusion of cars, or garbage trucks in this case. To fill this gap, we figured out that we had to find a way to transport the garbage autonomously without the use of cars. Our problem? To autonomously transport and sort garbage generated by inhabitants. Preliminary drafts. To figure out what our system of interest would be like, we drew some sketches individually and reviewed them in the group. This was very helpful, and we got some ideas about how our system would be. There were several interesting ideas that in the end gave us the input for our latest system of interest. Two of these drafts were nearly identical, and we chose to further explore their idea. The system of interest. As you can see in this animation, our system of interest became similar to some of our sketches. We can see from this sketch that our system of interest became to transport the garbage from the residence to the recycling station. We were interested in transporting it underground, thereby the tunnels that show the garbage flow. We can see the garbage being transported to its destination, which is the recycling station. This animation exists to give us an indication of the suggested garbage flow. To make the system convenient for the users, our vision was and still is to transport the garbage from within the house all the way to the recycling station. We believe that this is incentive enough in itself to make inhabitants want to use our system. We advertise this as easy to use. We will look further into stakeholders and their concerns later in this video. For now, let's look at some more models of our system. Scope. The installations are designed 1 to 3 meters underground to serve 250 homes in central Oslo and collect waste from an area of just over 80,000 square meters from various types of commercial activities. The installation is a vacuum system which both reduce the installation cost and minimize the burden on the city's inhabitants. We expect this type of installations to be carried out in many more towns and cities. 3 types of waste will be transported in the underground pipe system: general waste, paper, and food waste. The general waste will be sent for incineration and the paper and plastic will be recycled. The garbage transportation system will transport 300 kilograms of waste each day. The garbage will be transported about 2 kilometers from the collection point to the recycling station through 200 millimeter diameter piping. We're seeing several other towns and cities around the world using this type of system. This improves the working environment for both employees and cleaning staff whilst providing a much more efficient method of handling waste. City context. The original plan was to make a system for the entirety of Oslo. However, at a later date, we decided to focus on a smaller version of the system, where we only supply our services in a single new apartment complex that was constructed with our system integrated. This complex is located 2 kilometers from the recycling station. This was done to simplify our system for testing purposes. The system can later be upscaled to a larger underground network that is integrated in every building in Oslo. This citywide network is divided into neighborhoods, which are then divided into streets, and the streets are then divided into individual buildings. By dividing into these sections, we can simplify the control and monitoring process of our system. Specifications. Here's a black box view of our system. We can clearly see what the inputs and outputs are, power, garbage, and data in, and sorted and transported garbage out. Inside the black box, we have our functionalities, transportation and sorting. We have not yet defined how these functionalities will be performed yet, hence the black box view. However, as mentioned before in this video, we have vacuum power in mind. Stakeholders. Here is a model of our stakeholders and their concerns. We have decided to separate the stakeholders into 2 categories, the active and passive stakeholders. Each one of the stakeholders have their own concerns listed, and we have to have all of these in mind when moving further into the design process. Subsystems. We decided to categorize the system into 2 main subsystems: the collection system inside the building and the transportation system outside the building. These subsystems are divided further into smaller subsystems. Internals. This model shows the internals of our system. We can see the users on top that feeds the receiver with garbage. The user communicates with the system via a user interface. The input, garbage, then gets sorted and is transported to a storage unit. Further, the garbage travels to the collector system. The control room receives information from the sensors, which are spread out through the entire system and provide the real-time status of the system. An AI uses this information to decide how to regulate the system. The service personnel can override the decisions of the AI and regulate the system manually. In the end, we can see the garbage leaving our system and entering the recycling station. Key performance parameters. Here are our key performance parameters. These numbers are generated with the entirety of Oslo in mind. To provide a reliable service for Oslo City, our system has to be able to transport 500 tons of garbage each day. We have measured the maximum distance to be about 15 kilometers to the recycling station. The transportation part of our system will be placed 1 to 3 meters underground to keep it at a reasonable temperature during the winter months. The garbage is traveling at a velocity of 70 kilometers per hour. This is to reduce the chance of blockage and to keep the system at the right pace. As we can see in the power budget, 99% of the power goes to the turbines. The rest of the power goes to valves, sensors, and control system. We have estimated the amount of turbines, valves, and sensor we need. Solution alternatives. By using a Pew matrix, we can decide between different solutions. We came up with some ideas to compete against our current choice. We also have the present system as an option, the garbage trucks. We can compare these solutions by choosing key criteria that are important for our system. These criteria also need to be weighted for achieving correct results. After calculating the results, we got an indication of what solution was the best choice. The number one idea was using vacuum for transportation. At this point, we can conclude that in regards to this matrix, vacuum is the best choice. Concept of operation. Users throw their waste into ordinary accessible inlets, which can be either indoors or outdoors. Here, the bags are stored temporarily above a closed storage valve. All full inlets are then emptied at regular intervals. Automatic emptying is governed by a control system. When the control system senses that it's time to empty the inlets, a supply air valve is opened in order to allow air into the pipe system to transport waste from the inlets to the recycling station. The storage valves beneath the inlets are then opened one by one. The waste bags fall down into the underground network and are sucked away to the recycling station at speeds up to 70 kilometers per hour over a distance as long as 2 kilometers from the waste inlets. The inlets are placed on every floor, indoors, in the doorway, at street level, or even outdoors. Simulation. We have made a standalone executable app using MATLAB that simulates the garbage flow through the system. The largest plot shows the garbage level through time. The smaller plot shows whether or not the garbage is currently being emptied from the temporary storage units. At the bottom, we can see various pieces of useful information, such as the electrical energy consumption, the peak garbage level, and the percentage of time the system is on. This simulator is very useful for finding out what kind of values our different variables need. The variables can be given in different units for ease of use. The first three variables are the start values for the three different types of garbage. The next three variables dictate how much garbage is deposited into the system per unit of time. Next up, we can decide how long to simulate the system. Below that, we can specify the minimum amount of time between emptyings of garbage. The next one is the distance the garbage is being transported. The pipe radius determines how much air needs to be pumped per second. And the next variable down is the velocity of that air. The simulator is very useful to see the response of the system to unusual and extreme scenarios. And to close this video off, we have made a 3D animation of our concept.